calorimetry lab. What you're going to do is you're going to use a calorimeter, and in my calorimetry video I showed you one of these. You're going to use a calorimeter to measure ultimately the specific heat of an unknown metal, and you're going to use your reference table then to figure out the identity of your unknown metal. Now your lab sheet says listen to the instructor for what to do, so I'm getting ready to tell you what to do now. You make sure you listen. You're going to have to record a lot of data. At the bottom of your lab sheet there's a table where it has you write down all the data you're going to need. We're going to do a heat lost equals negative heat gained math calculations in order to find the specific heat of this metal in here. Now, let me ask you, if we take the metal that is hot and we mix it with cold water, what is happening? Where is the heat going? The heat is leaving the hot metal and is being transferred to the cold water, and it's going to continue transferring heat until they're at the same temperature. So that's what you're going to be doing. You're going to take some cold water, you're going to take a hot metal, you're going to combine them, and you're going to mix it up until they have the exact same temperature. Okay, so let me tell you what we're going to need. Before you start with your hot metal, you're going to need to get a volume of water. And the instructions don't tell you how much. I would say 50 mils is probably good. As long as the entire metal would be covered in your calorimeter, 50 mils would be fine. You don't have to get exactly 50.0 mils. Just write down whatever you get. If it's 48, that's beautiful. If it's 30, that's probably enough. I would shoot for between 45 and 55. But whatever it is, write it down. Don't take time to get it exactly to 50.0, because as long as you get the number written down, it doesn't matter. Now, the Q equals mass times specific heat times a change in temperature. There's no volume there. So how do we use that 50 mils? Do you remember that water has a density of 1? So 50 mils of water is also going to be 50 grams of water. So we've got the mass of the water. You're going to take a thermometer and you're going to measure the temperature of your water. That's your initial temperature of the water. Okay, when you've gotten your temperature and your mass of your water, I want you to head over to the front of the room where your teacher has all of the metals being heated in a beaker and a thermometer attached. Now, at that point, we want the water boiling. So if the water here is not boiling yet, you'll want to make sure you wait until this water is boiling. When she gets the metal for you, she's going to tell you the temperature. We've got a thermometer going here, so you'll be able to see the initial temperature. Now remember, if that metal's sitting in here with the water, that means that that temperature of the water is going to be the temperature of the metal. So probably the metal is going to be around 100 degrees Celsius. So what you're going to do is your teacher will most likely pull out the metal for you, and you need to have your calorimeter handy. And immediately that metal is going to be dropped in your cold water, and you need to get that lid on there quickly as possible. And I'm going to grab this thermometer, but you're going to have your own thermometer at your station that you're going to stick in the hole in the middle of your calorimeter, and you're going to use it not only to measure the temperature, but also to stir the solution. So you're going to stir your mixture of the metal and the water until, when do you know when to stop? You watch the temperature. The temperature of the water should be increasing because your temperature of the water was initially cold. You're adding hot metal to it. And as you mix this around, the temperature should be increasing. When the temperature stops increasing, that is your final temperature of the metal and the water. When you have that amount, you can go ahead and pull your metal out. Some of my students sometimes are like, but the metal's hot. No, you just measured it. It's actually just a little bit above room temperature. So you can pull the metal out and dry it off, and then you'll need to get the mass of your metal. When you're done with the mass of the metal, go ahead and return your calorimeter and your metal to the front of the room, and you can sit down and do your calculations. So it's a real quick lab, but in the end, we're hoping for some really good data concerning to be able to identify your correct metal. So do your calculations, then as a group decide what you think is the best answer for your metal. So I hope you have a lot of fun with this. Good luck.